Okay, so for polyatomic ions, the only difference, the total charge not equal to 0. Okay, so if I'm doing sulfate, one sulfate which is X, oxygen, there are 4 oxygen, one oxygen is -2, so total -8, and which is equal to whatever the charge. What is the charge of sulfate? -2. So we are going to write that -2. So X will be equal to what? +6. Okay, what is the charge you got for this one? ClO2 -1. You didn't get it? 3. Are you all agree with that? Okay, what about this one? +5 or -5? +5. And this one? -3. Okay. And this one? +2. Okay, now we are going to decide the oxidation or reduction. For that, there is a mnemonic we can, I don't know if it's mnemonic or abbreviation. It says OILRIC. OILRIC, the expansion is oxidation is losing electron and reduction is what? Reduction is gaining electron. Oxidation is losing and reduction is gaining. Okay? OILRIC. Okay, now let's do few questions. Okay? From here. Copy this. Oxidation is losing electron, reduction is gaining electron. Hey, so we have a couple of examples given. Oxidation state is also given, so that is easy, but you will not get that question on your AOL. You have to actually find the oxidation state. Okay, here it says Fe was 3 and it changes to what? 0. So what happened to the oxidation number? Look at the number line. Is it decreased or increased? If it is decreasing, what? It is reduction because it is decreasing oxidation number. Okay, next one. Cr2 plus was reactant. It has +2. Now it is +6. So number change from +2 to +6. Going to the right or going to the left? Okay, redox, remember. So this will be what? Oxidized. So number line will be like this, redox. If you are going to the right, that is oxidation. Going to the left, that will be reduction. Okay, next one. -2 to +2. Oxidation. Next one, -1 to 0. Oxidation. Good. Alright, now we'll see the actual question you are going to see on your AOL. These equations are not balanced. I'm not going to teach balancing right now. I believe now everyone can do balancing. Do you? Yeah. Okay. Let's see this. First question, we are going to find what are the elements from the reactant side undergo oxidation and which one undergo reduction, whether it is a redox reaction or not. Okay. So let's see. I'm gonna always whenever I see the single element, I will go write 0 there. So problem solved for that. Okay, now I have to find the oxidation. I am going to assign the oxidation state for each and every element. Oxygen is -2. and iron will be what? 3 times 2 minus 6, 6 divided by 2. We already calculated here, which is what? 3. So this is 3. Okay, here we don't need to calculate. We know that oxygen is minus 2. This will be plus 2 divided by 1. So that will be what? Plus 1. You are writing only one atom's charge on the top. Don't multiply this with 2 and write plus 2 there. Okay. You have to write only one single atom's charge on the top. Okay. Now, going to see which one undergo increase in number, which one undergo decrease in number. Okay, look at hydrogen. It changes from what to what? 0 to 1. Is it an increase or a decrease? That is an increase in oxidation number. So I'll say what is that? Oxidation. Go to the right. On a number scale, at a number line, that is oxidation. Now here, Fe, don't have space, I will write here, goes from what to what? Plus 3 to 0. So that is a decrease. So I have to write what? Reduction. Okay, question. Sometimes it will ask which element undergo reduction or which compound undergo reduction. So we can write both. Okay. Oxidation is what here? Hydrogen. From the reactant, we are writing only the, don't write H2O. Okay. Reactant undergo oxidation to become this. Okay. Which undergo reduction? Iron. So I will write iron 3 from which compound? Fe2O3. This is the whole thing is Fe2O3, but the one which undergo reduction is Fe3. If you practice like that, whenever you see question which compound or which element, you can answer both. Okay. Otherwise, you will get confused. Oh, this is asking for element. I don't know whether which element I have to pick. So we can avoid that confusion. Okay. Let's try the next one. Okay. Whenever you see polyatomic ion, same polyatomic ion on both sides of the equation, you don't need to find the oxidation number for each and every element because it is same on both sides. That means we know that no change happened. Okay, I'm going to do like this. Zinc is what? Single elements what? 0 and Ag 0. Okay, now nitrate is minus 1. There is only one nitrate. So what will be Ag? Plus 1 because the total charge must be equal to 0. Same strategy. Nitrate is minus 1. How many nitrate here? So total negative charge is negative minus 2. So this will be what? Plus 2. Okay, now we have to decide which one undergo oxidation, which one undergo increase in number. Okay, zinc goes from 0 to 2. So that number increased. I would say that is oxidation. Go ahead and write zinc undergo oxidation. Good. Okay, next one. Ag. Look at Ag. It was plus 1 in the reactant side. Now it is what? 0. So go ahead and write decrease here. So that is what? Reduction. So you can write Ag plus. That is the one reduced. Or you can write what? Ag from which compound? AgNO3. You all understand now? Let's try the next one. Okay, single element will write what? 0, 0, hydrogen is what? Plus 1. And how many hydrogens there? 3. So nitrogen will be negative 3. If you have problem, just do the algebra and find it. Okay. Now, which one undergo change in number? N. N goes from 0 to 3 and hydrogen goes from 0 to 1. So this undergo an increase. Increase what? Oxidation. So write hydrogen. Okay, nitrogen goes from what to what? Left. Okay, it decrease. So that will be what? Reduction. So you will write what? Nitrogen. Good? Question. Okay, try the next one and see. A few seconds. I'll give you 1, 2, 3 minutes. Okay, let's see. So I'm seeing nitrate on both sides, so I'll keep nitrate. I'll keep nitrate as nitrate. It is minus 1, hydrogen plus 1. Here also nitrate. There are 2 nitrates, so calcium will be positive. And I'm seeing OH on both sides. Did you see OH on both sides? Yes, because there is water, you can see OH in that. Water is HOH. So this will be minus 1. So if you are writing like this, okay, this will be minus 2, this will be plus 1. Okay, OH will be minus 1, OH is there, minus 1, calcium will be plus 2. Which one undergo change? Hydrogen is plus 1 on both sides. Nitrate is also same thing, calcium also same, everything, OH is also same. So that means it is not a redox reaction. There is not reduction and oxidation happened. So it is not a redox reaction. Reason? No change in oxidation number. All these equations are not balanced. Okay, I'm not balancing it. Yes. Yeah. No change in oxidation number. Okay, try the next one. Try the next one. Okay, number 5. Okay, you guys need to try. What is the charge of iron and oxygen? Oxygen is what? Minus 2 and iron plus 3. Okay, CO, oxygen is negative 2 and carbon 2. Here, oxygen 82, carbon 4 and Fe 0. Is it a redox reaction? Yes. Which one undergo increase? Which one undergo decrease? CO increased, which is oxidation, and Fe decrease, which is reduction. So go ahead and write it. Oxidation is C from CO. You can write C from CO. And reduction is Fe3 plus from Fe2O3. Yes. Here? No, you can just write the reactant's name, just showing which atom undergo change. Oh, that's what you said. Okay. Yeah, you had to do that. Okay, the question will be asking like this. Which element undergo reduction? Which element undergo oxidation? So you have to write only the element name, okay? Next one, Al2O3. 0, 0, and oxygen is -2, and this will be what? That's 3. So which undergo oxidation? Aluminum undergo oxidation because the number increased from 0 to 3. And which undergo reduction? Oxygen. Okay, go ahead and write that. Aluminum oxidation, oxygen reduction. Good? What about this? Waiting for me to do it? No, just to, you all done? Okay, -1 plus 2, -1 plus 1, -1 plus 2, -1 plus 1. Okay, which one undergo oxidation? None. So that is what? Not a redox reaction. Okay, next one. That is easy. 0, 0. What happened? Which one? Which one you want? Okay, sodium, you know the charges, you can find chlorine. Magnesium, you know the charges, you can find bromine. What do you mean by first one? Group 1 will be +1, group 2 will be +2. There is no exception for that. Okay, you can use that for finding the charge of other ones. And if you don't have, say for example, this one, look up. This one, you don't know both the charges as of now, okay? So we will assume halogens are -1, and so this will be +3. That's how we are applying it. Okay, now gallium changes from 0 to 3, so that undergo oxidation, and bromine changes from 0 to -1, that will undergo reduction. Okay, question. What type of reaction is this? We learned 5 different type of reaction. What are the 5 different type we learned? Synthesis, decomposition, single, double, combustion. Okay, what type of reaction is this? Combustion? Single replacement. Okay, next one. Next one. Is it double? Single. Next one. Synthesis. Next one. Double. This one.
Splitting. What is this? Yeah, what is this?
Wait, what? This is not the...
It's not a thing. Okay. Okay. So that's removal of atoms. So I'm gonna, this one get replaced. So I'm gonna write what? So one element get replaced. So I will go with a single. That's not a completely single replacement. You can write like that. It's a replacement. Okay. This one.
Combining.
Synthesis. And this will be double. And this will be why you have a problem with the combustion? Synthesis. Okay, now question. Which of these types are not redox? Double replacement will never be redox. So circle the following types of reaction always tend to be a redox. And double replacement will be only just interchanging the ions. There won't be any losing or gaining or transfer of electron happens there. So we can say double replacement. If you see a double replacement, you don't need to do all these things. You can just say it is not a redox reaction. Question. Yes. That's not a question. Yeah, you may. Any other question? Okay, so